All right, but now enough for me, right? Stage is yours again, and you will explain to the audience how to bring GigaBit interfaces with PoE, so how to power the field with power and data. So thank you very much. Have fun.
Thank you also very much. Yeah. Okay, now I need a pointer. Here I am again. So first of all, thank you very much to the Harting team for inviting me. It's really a pleasure to be here. Maybe you know the situation. You are invited to some birthday party and relatives of you, like your uncle, is asking you, which company are you working? Yeah, and in my case, then I say, I'm working for Würth Elektronik. And then my uncle normally says, or the relatives normally says, Würth, so you're doing screws. And then I say, yeah, this is our mother company. Yeah, I'm working for Würth Elektronik, and we do electronical stuff. And he says, yeah, what kind of electronical stuff? And then I see mostly EMC components. So everything that you can find on a circuit board except ICs. And the reaction normally is something like, okay, yeah. He did not understand anything. Yeah? Maybe this presentation now brings a bit more light into this question. But if my uncle is watching, if you're watching, Eugene, yeah, then please see this here. Yeah? This is our mother company, the Würth Group, yeah, with over 85,000 employees and about 20 billion of sales. They do everything, not only screws, also fixation stuff, or everything like hand toolings or things that you can find in construction markets, yeah, by direct selling, of course. And we are Würth Elektronik. We are a company daughter of the Würth Group. We are not that big. Yeah, we do our 1.3 billion in 2023. We have 8,200 employees, and we are present in 50 countries around the world. But besides this problem with what is your company, yeah, we have, of course, other issues that we need to deal with. And one of the biggest issues is, in the past years, many salespeople and FAEs come to us and say, Martin, your LAN transformers, this is very nice that you can provide. But the customers have questions. The customers want to know, yeah, what is around the LAN transformer? How can I connect the LAN transformer with the PHY chip? What is needed for everything? Yeah? And a long time I had to say, yeah, here's a presentation, there you can take out some slides. Or I found some information in internet, but nothing was really complete. Yeah, and so this was only piecework that we can give to the customers. And we wanted to change that. And therefore, my dear colleagues, Dr. Heinz Zenkner and Adrian Stirn, they worked on GigaBit Ethernet adapters, USB adapters. So they worked on a reference design. Yeah. We have, years ago, we did this GigaBit Ethernet USB-C adapter. And now, this is quite new, we also have a GigaBit USB-C adapter with PoE+. And this is what I want to tell you today, yeah, how to implement Ethernet on a circuit board. So when we see this circuit board here, so I only mention now this board with PoE, yeah, then yeah, we can see a lot of components here. To make it easier for you, you can see the small draft on the right side. So we have the data coming from the transformer, which is going down to the USB-C port. Yeah? But we also have the power, which is splitted on the LAN transformer, and this is going to the DC-DC converter. The DC-DC converter generates the power that is needed from the board, for example, for the chips. Here is the RJ45 LAN transformer, and yeah, as the cable is plugged in here, we start with that. Here you can see the chip. Yeah, this is the media converter from the RJ45 LAN signals to USB-C. This is the USB connector, so this is the path for the signals, and the power. This is going another path. You can see here. This is a power transformer, so we have up to 47 volts with PoE, and this transformer transforms this into 6 to 18 volts by providing a power of up to 25 watts. So this is a PoE plus system. And then we have here a feedback loop. This is an optocoupler. And you can also see this on the right side. Here there are some clamps where you as a customer can take out the current for your needs. And here we also have a chip and a DC-DC converter. And this DC-DC converter converts the energy, the 3.3 volt that we need for the chip. By the way, this board you cannot buy also. This board is available on our website. So you can go there to our website, you can download the application notes, you can download all the design data, so you can copy everything. And this is completely for free. This is what I want to mention to you still. So, and here is some scheme of our complete boards that we have. On the right-hand side, you can see the RJ45 LAN transformer here. And with the circuit to this. So this RJ45 connector is not only a connector, so there are magnetics inside and a small circuit board. So you can see here transformers, camo chokes. Later on, I go a bit more into detail here. Now I go into more detail here. So this is the RJ45. Let's see. So we have here the signal path. What we see inside is, in the middle, this is the transformer. And the transformer, the function of this is that if there are transients coming from outside, coming from the cable or coming from the, coming mostly from the cable, then this transformer is blocking this. So if there is a constant voltage, then the transformer is blocking this up to 1,500 volt. This is a must. This is written in the IEEE 802.3. But the signals, if signals are coming over the cable, then normally they should go one-to-one over this transformer. Also, there are camo chokes inside. In this case, we have camo chokes primary and secondary. This is for reducing common mode noise coming from the cable or coming from the chip. So, and then we have here, this is the power path. So while the signals go over the transformer, the power takes another way, or the current takes another way and goes to the DC-DC converter. Here we can see some photo of the inside of an RJ45 transformer. I was thinking this is interesting for people to see, so we can actually see here the ring cores or the toroid cores that are inside, and these toroid cores that you can see them also in the schematic. So the big cores, these are the transformers. In this case, there are 2 transformers for 100 megabit per second. For gigabit, we have 4 transformers, and the camo chokes on primary and secondary side also. Now we widen up the picture a little bit, and see what is between the transformer and the Ethernet controller. What kind of components we need here. And this is very interesting. You can see this picture on the right side here. It's very small, so we enlarge this picture now in the next slide. That's much better, And then we can see the components that are inside. First of all, on the right side, this is the LAN transformer. On the left side, this is the Ethernet controller. And here we have TVS diodes. This is needed also for transients coming over the cable to reduce those transients. In our case, in our application, in our reference design, you can see not all ports are used. This is the reason for this is it's easier to design. So we took 2 of those parts, and so we did not need to route so much. Those elements are very small. And then we have here on the LAN transformer a ground termination called Bob Smith termination. This is the small area here and the bigger area. This is also ground termination that we did. This ground termination is a bit special. we did this for EMI reasons, because we put our board, of course, the actual one in EMI testing, and so we also made a ground termination on the secondary side with 75 ohm resistors for the signals coming from the controller side. I'm switching now back to the last slide here to show how we designed this. Yeah, so those components are very small, and it's very important to put the TVS diodes very close to the transformer, and also the ground termination put also very close to this transformer. And here we can see this in this picture. I actually took out this picture from the application note of GigaBit Ethernet without PoE, because we can see this better here. Yeah? And what we can see in this red and gray and light gray lights is we put those components underneath the board. Yeah? And with this trick, those components are very close to the transformer, and therefore we have a very good ground connection. Talking about ground connection, this is also something interesting. We have questions from customers how we can connect grounds, because we not only have one ground, we have at least two. Yeah, we have somehow the chassis ground, but we also have some kind of analog ground. Yeah, and how put these things together? There are different solutions. Customers separated those grounds in the past, or they just put them together. But what is right? Yeah, how we can do this? And therefore, we also search for a solution, or we designed a solution, and there it is. Yeah. So when we see a circuit board, this is also the GigaBit Ethernet circuit board that we have. Then we placed some capacitors between this chassis ground and this analog ground. And we have different cases now. One case is you have a metal chassis, yeah, which is, of course, the best case. And we think on cables which are shielded. Yeah. In this case, you not need to place those capacitors. In this case, you just take those screws, yeah, you see the holes, and screw the board, fix the board on your chassis. Yeah. And then the grounds, they are combined with the chassis, and this is good. Yeah? If you have a chassis out of plastic, yeah, then we recommend that those capacitors are set, because then there's a defined path between analog ground and the so to say chassis ground, and this chassis ground then is connected with the land transformer and with the shield of the cable. When we look at the whole circuit board, then we see several of those capacitors around, yeah, marked in the field of 1 and 2. These are the capacitors that that we took to bring the analog ground and the chassis ground together. The capacitors on the field number 3, this is a bit more experimental stuff. Sometimes we see that the EMI gets better, sometimes it has no real function. So this is for the customers to test if this is maybe a better behavior then, if those capacitors are placed. Talking about how to make the routing. This is also a big question of the customers. How we should route our components. And here a little bit text for you guys to see some design tips for you. Yeah, if we this is of course the distances are a bit depending on the material, on the substrate, but we say the distance between two pairs, this is 0.125 millimeters, and the width of one line, this is 0.154 millimeters. And here on the right hand side, there are some design tips that we wrote together. You see more design tips in the application note. Yeah, this is just some bullet points that we highlight. For example, that not more than 2 millimeters should be between the capacitors and the IC pins, yeah, and much more design tips here. So, This was now the connection from the LAN transformer to the controller. Now we go to the other side, the connection from the USB port to the controller. This is also, of course, interesting. Also here we have the circuit on the right-hand side, and when I go to the next slide, this circuit is enlarged. There we go. Yeah? So the USB port is what you can see. This is the yellow big field on the left side, and on the right side, this goes to the controller. And also here, like for the LAN connection, we have TVS diodes in the middle. We have TVS diodes for the two high-speed channels, and we have 2 channels for the USB 2.0. Both take the same TVS diode. We have also CAM mode chokes in the signal channels. This is what you can see a bit on the right-hand side here. I don't know if I marked them. Yes, I did. Perfect. Therefore, we have two different versions. Yeah? So the upper 2 channel pairs, or the upper 2 channels and signal pairs, they use a more high-speed CAM mode choke because the signals are more high-speed. And the CAM mode choke below, this is for lower speed signals. Therefore, we need a higher inductance to have a good noise reduction in lower frequencies as well. And here, again, this is the TVS diodes like I mentioned before. So, this was in short, so to say, the USB-C port to the controller. Now let's go to the power path. And regarding the power path, there is to say, so we took over the design from a TI reference design. So this is not our invention totally, but we did some improvements on the design. Based on that, we have good EMI results. And there we can see this on the right side of the picture. You see, for example, the CAM mode choke that we did and the capacitors. This array, this is after the diode bridge. So after the transformer, there is a diode bridge, a rectifier diode. And between the rectifier diode and the DC-DC converter, there we have some filters here. We need big filters because the current is high. Yeah? So we need big wires. Yeah? And also the inductance needs to be high so that the CAM mode choke is very broadband. Yeah? And then we have big capacitors inside. This is the big capacitors. This is for the CAM mode signals, or to reduce CAM mode signals, and small capacitors. This is not marked here. This is for differential signals. Yeah. And what we can see here on the left side, this is also marked with 4 and 5. This is also some connection that we did. Yeah. The capacitors overbridge, or they bridge the different grounds from the power path and the signal path. So this is more or less the whole adapter that we have. And here with a picture. Maybe you're now saying, okay, this was very nice. We have now information about how to implement a gigabit USB adapter with PoE. Great, but is there any component that Würth Elektronik is providing for this board? Yes, there is. So we do the passive components and we do the screws. Not forget the screws. So last point from my side, the reference designs, where you can find them, of course. Yeah? You can find them on our website. For the GigaBit Ethernet reference design without PoE, we have 2 application notes. One application note is about a complete design. Why we use which filters, how to bring analog ground and chassis ground together and so on. Much more into detail that I mentioned it before. Yeah? And below there's an application note about the EMI testing that we did and design considerations referring to these tests. On the right side, the same thing. Here we have the application note to implement GigaBit Ethernet, USB, and Power over Ethernet. And we have also application note for the EMI testing of those. Both from my colleagues, Dr. Heinz Senkner and from Adrian Stern. So many thanks, guys, for this, for providing this application notes and for doing this design for us. That's it from my side. Many thanks. Many thanks for having me. And if you want to contact me, here's my email address.
Thank you very much, Martin. Thank you. Thank you very much for this contribution, and also I can tell that for the partnership with Würth Elektronik. So we all need the screws, but we are all into electronics. So thank you for being here. Okay.
Thank you very much.
Perfect. So I would also, Martin just said that, I would like to underline that. So our LinkedIn channels are all open. So my LinkedIn channel, but also from all our speakers, we have the LinkedIn channels open. We are checking the chat and are just like providing all the questions you guys are asking to the speakers, and you will get the answers during the day or latest tomorrow. And now we have a short break. So we'll be back here at 10:55 Central European Time, and get a coffee, get a tea, whatever you like, wherever you are. But please be back here 5 to 11. See you there. Bye-bye.